Salam and welcome everyone. So today we're going to be working on the question on the screen that says the standard enthalpy of formation of phenol C6H6O is negative 165.0 kilojoule per mole. Calculate the standard enthalpy of combustion. So the first thing you have to note is this. You have the question telling you that a reaction has taken place, which is C6H6O liquid has undergone a combustion, which is just whatever the molecule is plus oxygen gas. So it reacts with oxygen gas to get carbon dioxide and water. So this is what happens in all combustion reaction. An organic compound reacts with oxygen to give you carbon dioxide and water. So the next thing you have to do is to just balance the chemical equation. Of course, you are going to get the liquid. Sorry, you're going to get oxygen. The phase for the oxygen gas is gas phase. Carbon dioxide is a gas phase. But in the case of water here, it's a liquid. So yeah, that's it. So phenol reacts with oxygen gas to give you carbon dioxide gas and liquid water. So that's it. The next thing you have to do is to balance the chemical equation. So I'm going to do that right here. To balance it, we have to make sure that what is on the right side, the number of atoms on the right side, matches the number of atoms on the left side. So I put 6 in front of carbon to make sure I balance the carbon. I put a 3 in front of hydrogen to make sure I balance hydrogen. So hydrogen is also balanced. So just oxygen left. So you have 3 oxygens on the right and then 12 again. So 12 plus 3 is 15. So in this case we have just 3. Well, if we put a 7 here, 7 times 2 is 14 plus 1 15. So we have the carbon, the hydrogen and the oxygen balance, and this is simply the balanced chemical equation. So using this information, we can now calculate the standard enthalpy of combustion. Note that the standard enthalpy of combustion is the same thing in this case as the standard enthalpy of reaction. Because a combustion is a reaction, we can just substitute the standard enthalpy of reaction with the standard enthalpy of combustion because it's basically the same thing. So just putting that in mind, we can now write the equation that we'll be using. So the standard enthalpy of combustion to be equal to the sum of the standard enthalpy of formation, okay, minus the sum of the standard enthalpy of formation as well. So you may be wondering, why are we subtracting the same thing? We're not really subtracting the same thing because here we're dealing with products first. So we're going to be dealing with the standard enthalpy of formation for products, and then we're going to do minus the standard enthalpy of formation when you add them all up for reactants. So basically, this is the summation symbol. So you're just going to add them up. When I do more of the problem, I'm going to like explain it to you guys bit by bit. So rewriting all of this information, we have the standard enthalpy of combustion is going to equal whatever it is for the product. So you have 6 times the standard enthalpy of formation for carbon dioxide gas. So this CO2, right here has a coefficient of 6. So 6 is going to have to come out here, okay? Plus, because the summation is telling us that we're going to sum things up, plus 3, okay, times the standard enthalpy of formation for H2O liquid, okay? It's very important that you don't mess up the phase because H2O liquid, H2O gas, H2O solid will give you different values when you go on to check the standard enthalpy of formation in your resource section of the book, or if you go on Google, you're going to see that you have different values. So make sure that you're putting in the right phase whenever you're doing this portion of the work. So minus, because now we're done with the products, now we have to do with the reactant. So minus the standard enthalpy of formation, okay, of the of basically C6H6O liquid, okay, plus the standard enthalpy of formation for O2 gas. So that's basically what we have. So yeah, standard enthalpy of combustion is going to be 6 times the standard enthalpy of formation of CO2 gas is just 6 times negative 393.51 kilojoule per mole. Now, before we go on further, let me explain to you what's going on here. You see the standard enthalpy of everything that I'm underlining with the wavy line, they have an exact value. You'd have to go to the resource section of your book, right, as I'm doing this work, and you're going to be checking them out. So that is what I'm not going to write all of that information out here for you guys, because I want a situation where you guys will be able to like answer questions without depending on me explaining it. So you have to go to the research section of your book to find the standard enthalpy of formation for CO2 gas, for H2O liquid, for phenol C6H6O liquid, as well as for O2 gas. When you have that, then you can substitute, which is what I'm doing. If you don't have, if you don't know where to find it in your book, it's usually at the back of your textbook, or you can go on Google and like as I'm working on this, have like open another tab on your phone or on your computer and be googling it, and you're going to see that I'm putting in the exact value. And if you don't have, if you don't want to use your phone, please use your textbook. So plus, okay, plus 3 times the standard enthalpy of formation for H2O liquid is, looking at my textbook, is 3 times negative 285.83 kilojoule per mole. Okay, minus, okay, minus again, because the standard enthalpy of formation for phenol, well, we're not given that. And actually, we were given that, meaning this is the whole point of the question. The question says the standard enthalpy of formation of phenol is this, meaning it's possible that you don't find that in your textbook, right? So this one was actually given to us. And so this is the value we're going to use. We're not going to use the words on the textbook for now. We're going to use this value that we're given. So that's going to be minus 165.0 kilojoule per mole. So make sure you also always go back to your question, right? Okay. Sorry, not a bracket. I meant to write a plus. Plus the standard enthalpy of formation for O2 gas. And we see that to be 7 times 0, because that's the standard enthalpy of formation for O2 gas is just simply 0. So we just basically work on this. So 6 times negative 393.51, that's just basically negative 2361.06, okay, kilojoule per mole, plus the other product 3 times negative 285.83 kilojoule per mole is just simply going to give us negative 857.4749 kilojoule per mole. Okay, so that's it. And then you have minus minus, which I can just call plus 165.0 kilojoule per mole. Of course, 7 times 0 is 0. So, yeah, so changing enthalpy of combustion is going to now equal negative 231. Sorry, changing enthalpy of combustion is now going to equal negative 2361, okay, 0.06 kilojoule per mole plus 857.49 kilojoule per mole. So that's going to give you, give me a second. You know what I just realized? I just messed up. I put a plus here, which is importance of like looking back at your work. I put a plus here when 3 times negative 285, when I should have put a minus here. So that would be negative this, negative that. So negative 2361, because negative 393.51 times 6 is what this is, plus negative 285.83 times 3. So I'm supposed to get a negative 857.47 kilojoule per mole. This is important. This is the reason why you have to focus on not making mistakes and consistently cross-checking your work. So you have negative 3218.55 kilojoule per mole. Okay. Plus 165.0 kilojoule per mole. Okay. Change in enthalpy of combustion is now going to equal negative 3053, okay, 0.55 kilojoule per mole. So if you go back to the question, you would see that we're giving our question in 1 decimal places. So 1 decimal place. So we have to do the same thing here. We have to do it in 1 decimal place. So what's going to just happen is me going to rewrite it, the answer in 1 decimal place. So that's going to be negative 3053.6 kilojoule per mole. So this is the answer in 1 decimal place. So this is basically how you do this problem. If you have any questions, please put in the comment section. If you would want me to if you would want me to do other topics that are of interest to you, please put that information in the comment section, as well as any concerns and suggestions that you may have. I wanted to mention that if you're a student who is trying to succeed in all your STEM related courses, whether you're in high school, middle school, or college, make sure you email me at tutoring@gmail.com. I help students succeed in all their STEM related courses in high school, middle school, and college level. I also help students with test prep and students who may be struggling in school, and or students who are just confused and are trying to look for a balance. You can email me at tutoring@gmail.com for any questions or personal issues or struggles relating to academia. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.